Hello learner, welcome again to Manifested e-learning platform. My name is James Kenyani. We are going to proceed with our topic on three-dimensional geometry, and as usual in the lesson, we are going to solve the two questions that I had given you in the assignment. So objectively, this lesson is to give you an in-depth experience in solving question on three-dimensional geometry. So I had given out two questions in number 16 and number 17. We shall start with number 16 from Mathematics for Schools by Patel. Question 16. A is a foot of a vertical post. The top B of the post is connected by straight wire to points C and D. At the same level with A. It means the points are at the same level with A. So where ACD is a right angle and AC is equals to CD is 15. So the best you can do in such a question, you sketch out something to help you. So you go to solutions. Question 16. And I've said you sketch out. So this is the vertical post. That is your post. The foot is A, the top is B. So this is the foot A and the top is B. That's why they are calling it AB. So the top is connected to 2 points. I can assume my first point is here. It is connected to C at the same level with A. It means this is the same level with A. So it is at the same level with A by straight wire. So where ACD is a right angle, ACD, so there is a point D there. So you are told this is a right angle. Come rain or shine, that is a right angle. So this is also the wire. So this is a wire and that is a wire. These are the two wires. So is there anything also given? Yes, AC is 15 meters. CD is 15 meters. Angle AC, think it's angle ACB, angle ACB, sorry for that. Angle ACB. Angle ACB is 20 degrees. So after having that sketch, it is very easy for you to move. You have that sketch. So I've absorbed all that is in the question. I've put it into a sketch where this is the vertical post. Vertical post. And these two are my wire, a taut wire, a wire. So what are the questions? The length AB, AB. So if this is right, if this is level ground, this will also be a right angle. So when you go to AB, you'll use the tangent, opposite of adjacent. You'll say tan, solution A, tan 20 degrees will be equal to BA or AB divided by 15 meters. That's why they say the prerequisite knowledge in this three-dimensional topic was trigonometry. So you should know the tangent ratio rule, tangent ratios, cosine, etc. So cross multiply AB will be equal to 15 times tan 20 degrees. A quick punching of the calculator. A quick punch of the calculator will give you, if you multiply these, a quick punch of the calculator gives AB is equal to 5.459 meters. That is length AB. What is next? The angle of inclination of BD to the horizontal. BD to the horizontal. So if you want to get that, BD to the horizontal, they are asking for angle theta. You'll be forced to get DA. I already know BA, so you'll come to B. Extract your right angle triangle. Required, I know I have BA. DA I don't have, but I know this is a right angle. So I'll get it from triangle CDA. CDA. So I'll first of all get DA. Look at the diagram, DA. This is a right angle triangle. So the square of this, the sum of the squares of 15 and 15 will give the square of A. So this is DA, the square of DA. So DA squared or DA is equal to the square root of 15 squared plus 15 squared, because the other one is a right angled triangle. This will come to DA will be equal to 15 squared is 225 plus 225, which gives us the square root of 450. You get DA is the square root of 450. If you calculate that using your calculators, you'll get the square root of 450 as 21.21. So DA is 21.21 meters. That DA, and this I got it as 5.459. It helped me to get that angle of inclination theta. So we'll move here quickly. So I'm looking for theta. That's the angle of inclination of BD, angle of inclination BD with the horizontal. So I'll use these. I'll say tan theta from that triangle will be 5.459 plus 21.21. That is opposite over adjacent. This will give me what? You punch with your calculator, quickly with your calculator. You have 5.459, 5.459 divided by 21.21. You'll get 0.2574. 0.2574. Therefore, theta will be equal to tan inverse 0.2574, and that angle of inclination from the calculator inverse tan 0.2574 will be 14.43 degrees. 14.43 degrees. That is the angle of inclination. So you look at the tips, the steps. We move to C. Angle between CB and DB. C. Look at C. Angle between BC. They are looking for this angle. I can call it alpha. They are looking for that angle. This is the angle between BD and BC. So you'll extract this right angled triangle. You'll extract that. It is this triangle. We'll use these. This is 15 meters. This is D. This is C. This is B. So they're asking the angle between BC and BD. CB and DB. It is this angle. CB and BD. CB and BD. This one, CB and BD. They are looking for that angle, alpha. They are looking for that angle, alpha. So I should have two ratios in order for me to get it. So I have this one, but I don't have that one. I should get CB. CB is equal to, you'll use the ratios. This is 15. CB, adjacent hypotenuse. So you'll say cosine. You'll say cosine 20 degrees is equals to the adjacent, which is 15, over the hypotenuse, BC. So BC, you look well, it will be 15 divided by the cosine of 20. 15 divided by cosine of 20. What does that give us? Go to a calculator. 15 divided by cosine of 20. It will give us 15.96. 15.96. So this is BC. 15.96. So they want that angle. So we'll say tan beta is equal to opposite of adjacent. So that is 15 divided by 15.96. So the calculator here is of utmost importance. 15 divided by 15.96. It gives you 0.9398. 0.9398. So that angle in question, beta, will be equal to tan inverse 0.9398. And that angle of inclination move to tan inverse 0.9398. It gives you 43.22 degrees. 3.22 degrees. So angle of inclination, angle between BCB and DB, this angle, it will be 43.22 degrees. We are done with question number 16. We move to 17. We are moving to question 17. So if you have your pen, mark your answer. You'll see whether you got it correct or you got it wrong. This is the opportunity for you to check where you went wrong. So we move to question 17. Question 17. So A, you read the question in the figure given. In this figure below, PQRS is the base. PQRS is the base of a square. Below the square, in the figure below, the square PQRS, it is a square with a horizontal base of a right pyramid, which is cut by plane KLMN horizontally parallel to the base, and there is a vertex V. That is the vertex. So what is the question? The vertex V of completed pyramid is vertically above the centers A and B. This is the center of that horizontal plane, and B is the center of that square base of the pyramid. So you are told VA V from this point to that point, you are given, it is 15. VA is 15 centimeters. So to solve this, you need to extract a figure that will help you to solve, because the first question is calculate the length of AC. AC, there is a length here. So I'll be forced to extract that triangle. I'll extract this triangle, where the base now, since this one is from that explanation, this is 12 and that is 12. That is 12 and that is 12. Given that that is 12, PQ is 12, half of PQ will be 6. So this will be 6. And we are given VA was 15 and AB is 5. So the whole of this is 20. From the top of the vertex to the bottom, it is 20. So the distance they are asking for is A to C. It is actually here, A to C. I don't know that length. I don't know that length, but I know this one was 5 and the other upper one was 15. So I can use similarity and congruency. Similar triangles. I'll use similar triangles. The small triangle, if I give the vertexes, V, this is A, that is C, this is B, and I can give here a new letter X. You look at this triangle, VBX is similar to VAC. Triangle VBX is similar to triangle VAC. So using similarity, by similarity, if I take BX, I divide by AC. It's the same as taking VB divide by VA. And in fact, those ones are given. VB is 20, so BX is 6. AC is not known, it is X. Should give me VB, which is 20. VA, it is 15. So by cross multiplication, 20x, by cross multiplication, 20 times x will give me 6 times 15. So the value of x will be 6 times 15 divided by 20. 6 multiplied by 15 divided by 20. So 5 goes there 2, 5 goes there 4. So it's actually 12 divided by 4. 2 goes there 1, 2 goes there 2. 1, 3. The value of x is 3 centimeters. So length AB, length AC is 3 centimeters. We move to the second question. So I'll wrap this one because I'll still use that figure. I'm still using the figure. We are moving to B. Angle of inclination of LMQR. LMQR, they're asking for that angle. They're asking for this angle of inclination of LMQR. So you come to B, extract the same triangle, BX and V. They are asking for theta. This will be the angle of inclination of LMQR to the horizontal. But I know here it is 20, and I know here it is 6. So I'll say tan theta is equal to 6 divided by 20. Not 6 divided by 20, but opposite, VB over BX, which is 20 divided by 6, which gives me 20 divided by 6, 3.3333. So theta is equal to tan inverse 3.3333. Punching the calculator, tan 3.3333, 73.3 degrees. 73.3 degrees. Lastly, volume of the truncated pyramid. They are talking of this. That is the truncated pyramid. So to get that, you should get the volume of the larger pyramid, subtract the volume of the smaller pyramid. So that volume, a volume of a pyramid is given by a third base area times height. So there will be a big base area and a small base area. So I'll write a third B base area height, subtract a third small base area times height. So the small height is VA, which was given as 15. So I'll just substitute. I'll come to a third. The base area of the bigger one is 12. 12 times 12. The height, complete height is 20. subtract a third times the small base area here. If I got this was 3, if I got AC was 3, it means that to complete this would be 6. That would be 6. If I got that one was 3, to complete that would be 6. Let's see what we got here. Let's just check here the length. See whether we worked it well. Let's see our workings here. 6 times 15 divided by 20. 4 goes there, 5 goes there, 3, 5 goes there, 4. So this was supposed to be, 4.5. So check, this was 4.5. It's always good to check. It was 4.5 centimeters. So this will give this one here as 9. That would be 9. So it will be times 9. Times 9. The height there is 15. So you just multiply 1, 4. This is 1, 3. So that one works to, C works to, finally works to, you check the tips and how we move to the answer. So you check, get your calculator, come here. So you come here, 4 times 12 is 48. 48 times 20. So it's 48 times 20. You get 960. Subtract, this is 27 times 15. 27 times 15. You get 405 cubic centimeters. You subtract these, you'll get 555 cubic centimeters. So it is a time to check your workings. It's time to mark. Just make sure you rectify here where we went wrong. 3, we said 5 should have gone there 3, and 5 there 4. So you got 18 over 4, which gives you that. So having got at that place, check your answers, because the joy of a student is getting the correct solution, being able to go through the solution. So for the assignment, in mathematics for schools by Patel, we do exercise 5.2, number 18 and 19. So at that point, go through your working and see where you went wrong and continue practicing. So at that juncture, I end the lesson, and I hope you'll enjoy going through the working of 18 and 19. So thank you and bye-bye.